Up to now, we discussed indeterminate expressions in the form 0 divided by 0, or infinity divided by infinity, or 0 times infinity. Now let's consider a slightly more difficult case, infinity minus infinity. If we have a difference of two functions, we can multiply and divide by the product, and we can rewrite this as a ratio of two expressions. When a and b both go to infinity, then here both numerator and denominator go to 0. And this is useful for the L'Hopital's rule. Something in this sense can be done for this limit, for example. Limit of 1 over x minus 1 over logarithm 1 plus x. If x goes to 0, say from the beginning, let's write x goes to 0 from the right. Then this goes to infinity. Logarithm of 1 is 0. So if x goes to 0 from the right, then this goes to 1 from the right, and logarithm of an argument that goes to 1 from the right goes to 0 from the right. So this fraction goes to infinity as well. And we have the indeterminate expression infinity minus infinity. We can rewrite it in this form, which in this case means that we actually bring the two fractions to common denominator. X times logarithm of 1 plus x. And in the numerator we have the difference, logarithm 1 plus x minus x. And now when x goes to 0, this bracket goes to 1, logarithm of 1 is 0, this is also 0, so the numerator goes to 0, and here this whole logarithm goes to 0, this goes to 0, and we have 0 divided by 0, so we can try the L'Hopital's rule. This is actually in this form because if you consider a to be 1 over x and b to be 1 over logarithm of 1 plus x, then here we have 1 over b, which is logarithm, minus 1 over a, which is x. And here we have the reciprocal value of the product. The product is 1 over x times 1 over logarithm, and the reciprocal value of the product is x times logarithm. So the L'Hopital's rule can be used, and we have logarithm of the numerator, logarithm derivative. Derivative of logarithm is 1 over the argument, 1 over 1 plus x, minus derivative of x is 1, and here we have product. Derivative of the product is derivative of x, which is 1, times logarithm 1 plus x, plus x times derivative of logarithm, which is 1 over the argument, so this is 1x divided by 1 plus x. Now, if x goes to 0, this fraction goes to 1, and 1 minus 1 goes to 0. This bracket goes to 1, the logarithm goes to 0, and this fraction goes to 0 because x goes to 0 and the numerator goes to 1. So we have again 0 divided by 0, so we can once again try the L'Hopital's rule. And we have limit for x going to 0 of fraction. The derivative of 1 over 1 plus x is 1 plus x to minus 1 So this is minus 1 plus x to minus 2. And 1 is 0 when differentiated. And derivative of logarithm is 1 over the argument plus, and this is a fraction. Derivative of the fraction is square of the denominator. And in the numerator we have u derivative v, which is 1 plus x, minus uv derivative, which is x. Well, and now if x goes to 0, this goes to 1, x minus x cancel, and 1 over 1 is 1. So the whole numerator goes to 2, and if x goes to 0, this goes to 1, so the result is minus 1 over 2.